Hello, third grade. Today we're going to look at Chapter 3 of the Solar System unit. The title of this chapter is Earth's Movement. The big question for the chapter is, how does Earth move in space? Focus on where you are right now as you read this. Are you moving? Yes, you are, even if you are holding very still. Planet Earth is moving, so you are moving with it. Because of the tiny size compared to Earth's size, you cannot feel Earth's movement through space. But relative to the Sun and other objects in space, Earth is in constant motion. Although you cannot feel Earth's motion, you can observe clues by looking to the sky. Think about riding on a park merry-go-round. On one side of the merry-go-round are trees and a bench. You see them speed past you as you spin. Around you go. In another direction, you see a swing set and climbing bars pass by. But are the trees and swing set really passing by your field of vision? No, it's you and the merry-go-round that are in motion. This is what happens when the sun and the stars seem to move across the sky in the day or the night. Earth is spinning, so you move beneath the section of the sky where those objects are visible. Earth rotates on an axis. So if you think of a lollipop, you have the stick and you have the ball, the sphere. So the axis is where it tilts. Or if you've played with a dreidel before, it's the top of the dreidel that spins it. That's where the axis is, the middle of the sphere. So Earth rotates on an axis. A merry-go-round is a flat shape that spins. Earth is a sphere, the shape of a ball. Earth rotates around its axis. An axis is an imaginary line through the center of an object. The axis is a fixed point of reference. And in this picture I can make an observation. The sun must be on this side, which means that half of the Earth is daytime, where the opposite side is at nighttime. And you can see that there's parts of the day as it gets darker and darker at night. You would see Florida, New York, Atlanta, they would become darker quicker. Whereas in California, it would be a little bit delayed. What you see in the sky depends on where you are on Earth's spherical surface. Two people on opposite sides of Earth's surface see different things when they look to the sky at the same time. One sees night and one sees day. And what you see in the sky changes. It depends on which direction your location on Earth is facing at any given time. Earth makes one full rotation around its axis every 24 hours. So here's Earth, third rock from the sun, and it twists every 24 hours, which makes it one day. Throughout the course of the day, the sun appears to move across the sky. When the sun is not visible at night, patterns of stars become visible. They too appear to move across the sky. But remember that this is apparent movement. Earth's motion changes where these objects appear in the sky. If you observe the apparent movement of the sun and stars, day after day and night after night, a very clear pattern emerges. They move across the sky from east to west. Earth spins from west to east. As you, at the point of the Earth's surface, spins past objects in the sky, they appear to be moving in the direction opposite of where they're actually moving. Shadows change throughout the day as the position of the sun changes. This is evident that there is movement in the system that includes Earth and the sun. So if you have the sun over here, you'll see the shadow come on this side. Sun over here, you'll see the shadow come here. So like they said, rises in the east, midday, high noon, and then sets in the west. The sun's path across the sky is always from east to west, but the shape of its arc depends on the season and the location. And as you know, based on the season it is, the month that it is, you have the sun sets anytime between 4:30 and 9 o'clock, just based on when it is. Earth revolves around the sun. In a single day or night, you can see evidence of Earth's rotation. This is evidence that Earth spins on its axis. But you can also see evidence that Earth is moving in an orbit around the sun. As Earth moves in its orbit, we can see different constellations. Constellations appear to move across the sky every night. This is evidence that Earth spins around its axis. In addition, visible constellations change with the seasons. This is evidence that Earth also orbits the sun. So it's a bunch of clues that give us a better picture. In Earth's orbit around the sun, the nighttime side faces different regions of space, with different constellations during different seasons of the year. Stars that are visible during summer nights are on the daytime side of Earth during the winter, so they are not visible then. And that's it, quick one. So here, during different seasons, Earth's nighttime side faces different regions of outer space. So in different seasons, we see different sets of stars in the night sky.